Welcome to This Explainer. Today, we're diving straight into how an absolutely incredible initiative called Soil Solutions Ghana is merging dirt, data, and human action to completely revolutionize agriculture. But at its core, this isn't just a tech story. It's a story of farmer advocacy. We're looking at a system that takes the very ground we walk on and connects it directly to the cloud to tackle one of the most pressing issues of our time: global food security. So before we get into the nuts and bolts of how this all works, I want you to really think about this contrast. On one hand, you have high-tech artificial intelligence, right? Servers, algorithms, machine learning. And on the other, you have the grounded, incredibly physical reality of rural farming. Historically, these two worlds have been kept completely separate. The tech sector kind of loves to build in a vacuum, deploying tools from glass offices that just don't translate to the field. But today, we're exploring what actually happens when enterprise-level AI rolls up its sleeves and gets its hands dirty. Here is our roadmap for today. We'll quickly cover the agricultural knowledge gap, dive into the Asaasepa Test Kit hardware, explore the pharmacist chatbot, look at the synergy between tech and humans, and finally wrap up with scaling global soil solutions.
All right, kicking things off with Section 1, the agricultural knowledge gap, or as it's often experienced, farming by guesswork.
There is this massive, systemic extension gap in agriculture right now. The absence of real-time expertise literally leads to systemic soil degradation. In so many remote communities across Africa, and specifically in Ghana, farmers are basically forced to gamble their entire livelihoods on guesswork. Imagine your crops are failing, or you're gearing up for a new planting season, but to get an expert to diagnose a disease or check your soil quality, you have to wait weeks. By the time that agricultural extension officer finally shows up, your planting window might be completely closed, or the crop is already a total loss. Look at this contrast. Traditional farming relies on super generic regional advice and waiting forever for lab results, which inevitably leads to wasted fertilizer on misdiagnosed soil. Farmers are out there buying fertilizers their soil can't even absorb because the pH levels are totally off. But precision agriculture flips this entirely on its head. We are moving away from a broken, painfully slow system into a future of instant, hyper-localized insights. Actionable data is now what dictates crop survival. Moving right along to Section 2, hardware, specifically the Asaasepa Test Kit. This is analytics right in the palm of a hand. Enter the Asaasepa Soil Test Kit. And let me be clear, this isn't just some basic tool. We're talking about a proprietary, highly affordable IoT hardware probe designed specifically for the harsh realities of the field. It completely bypasses those distant, slow remote labs. By utilizing accessible on-site hardware, it connects the raw power of a traditional laboratory directly to the farmer. It literally scales laboratory-grade analytics down so they fit right into a smallholder farmer's pocket. The benefits here are huge. The Asaasepa kit generates instant physical and chemical diagnostics. You stick it in the mud, and boom, it measures precise pH levels and essential baseline nutrients like nitrogen, phosphorus, and potassium on the spot. Immediate data means immediate action. Farmers know exactly which crops will thrive before they even spend a dime clearing the land, optimizing their input costs from day one. Plus, the absolute second that probe hits the earth, all that rich raw soil profile data automatically syncs straight to the cloud. Which brings us perfectly to Section 3, AI the Pharmacist Chatbot. Think of this as your personal digital extension officer. True inclusivity means speaking the farmer's language. I absolutely love this quote from Soil Solutions Ghana, because let's be honest, building a sophisticated AI model, that's actually the easy part. Getting a smallholder farmer to trust that AI with their family's livelihood, that is the real challenge. Pharmacist bypasses all those literacy and language barriers by communicating in multiple local dialects. They recognize that if enterprise-level AI isn't accessible to the person actually standing in the mud, then the tech has completely failed. So what does Pharmacist actually do? It functions as a virtual extension officer. It ingests that raw, hyper-localized data synced from the Asaasepa kit and then analyzes it alongside historical land metrics and satellite imagery. We aren't just presenting raw numbers here. This AI models predictive crop outcomes, dictates exact fertilization needs, and even delivers real-time pest intelligence. It takes complex data and turns it into a climate-smart, resilient strategy, helping farmers predict climate shocks and adapt to our wildly unpredictable weather patterns. And here is the absolute game changer for field adoption. The actionable guidance is delivered via simple, plain-text agricultural directives directly to a basic mobile phone through SMS. You don't need a computer science degree. Heck, you don't even need a smartphone in many cases to use this.
It is quite literally a digital agronomist in the pocket of every smallholder. Highly personalized guidance is now just a text message away. Let's pull this all together in Section 4, Synergy, Tech and Humans, and what we call the real-time outcome loop. This step-by-step outcome loop is the ultimate synergy. You have the Asaasepa hardware, the pharmacist AI, and most importantly, human actors, the farmers, extension officers, and laboratories, all perfectly aligned. This is what makes AI farming tech grounded and genuinely impactful. Real trust is built when data-driven AI meets community agronomists right there in the field. It makes true soil science a reality, completely within the reach of everyday smallholder farmers. Finally, Section 5, Scaling Global Soil Solutions. Let's look at proving the actual impact of all this. 11,548. That is the exact number of smallholder farmers currently supported by Soil Solutions Ghana. These aren't just data points. They are real individuals and real families whose livelihoods are shifting from stressful daily survival mode into true, sustainable agricultural prosperity, all thanks to this exact synergy of the Asaasepa kit and pharmacist AI. And look at this massive number, 996,848. That's nearly 1 million acres of farmland tested. To put that into perspective, this proves that this infrastructure isn't just some digital novelty sitting in a Silicon Valley presentation deck. It is actively deployed in the mud, it is successfully scaling, and it is actively restoring the health of our soil on a massive scale. And the world is definitely taking notice. Earning a finalist spot at the 2025 AI for Good Global Summit in Geneva, Soil Solutions Ghana proves that this is a globally scalable model. But beyond the accolades, it shows that people make AI for good. When AI for the planet is driven by true farmer advocacy, it empowers everyday people to create a measurably better world. So I'll leave you with this final thought. If we have the technology right now, the IoT hardware, the generative AI, and the community trust, how quickly can we democratize these tools worldwide? It is a truly fascinating question as we watch technology and passionate farmer advocacy unite to create a climate-resilient future. Thank you so much for joining me on this explainer today, and I really hope this mud-to-machine synergy leaves you as inspired as I am.